Alright, so what we're talking about then is we wanted to talk about compound inequalities. Okay, so compound inequalities were any kind of inequality where we have two things, right? So if we say 1 is less than x is less than 5, that gives us an interval. Okay, so like we looked at before, this is going to give us an interval like 1, 5 is all the values that'll be true for this. So we're going to look at solving some compound inequalities. And all it really is we want to trap x in the middle. Now we wanted to remember two important things when we were working on these. The first one is when we had a negative and we needed to multiply or divide by that negative, that we had to make sure that we flip those inequality signs. Okay, that was one of the number one most important rules. The other is that when we get our solution, we should get an interval like this as part of our solutions, instead of just 1 or 2 values for x. Okay, so we're going to look at some examples of that. So here we have 7 is less than x minus 7 is less than 15. So we want to isolate that x. We want to trap it in the middle. So to do that, we're just going to add 7 to all three pieces. Right? We're basically just solving two problems at the same time. So that's going to give us 14 is less than x is less than 22. Okay, so we're going to take this, and if we're going to plot that on our number lines like we did those other problems previously, then we're just going to get an interval like this. Okay, and what we're saying is this whole area in here, all of these numbers are true for this compound inequality. Okay, so we're trapping that x value in the middle. We're finding where that x value lives at. So then also remember, I said once we found our solution area here and we put it in our number line here, we can take that and put it in our interval notation by just translating what we've already done straight down into the interval. Okay, and that kept it nice and simple for us, and we really liked that. So this is our whole answer here. Okay, so remember we had three ways we could write our solutions. We can write them as an inequality, like here. We could write them as on a number line, or write them graphically, and we can write them as an interval. Okay, so that was the basic idea of what we needed to do here. So let's look at a couple more examples. So here it's going to work the same way. If we have less than or equals instead of just less than, we're going to do the same thing. We want to trap that x in the middle. Okay, so we're going to add 4 to each side. So we add 4 to negative 4 and we get 0. And that's going to be less than or equal to 3x minus 4 plus 4 is just going to leave that 3x there. And then we're going to add 4 to 6 and it's going to be 10. Okay, so then we're going to divide each of the three parts by this 3 so we can get that x by itself. 0 divided by anything is just 0 again. Is less than or equal to x is finally by itself. Is less than or equal to 10/3. Okay, and it's fine to have fractions in our intervals. We don't mind that at all. So then we're going to make our little number line here. Okay, and remember when we had less than or equals, we want to use these square brackets in our notation. Okay, so that's going to go from 0 up to 10/3. And again, we're saying all these x values in here, this is where our solutions live. Everything in there makes that true. Now sometimes we might have to multiply. And another thing to watch is if we have, like here we have it less than or equals, and here we just have less than. Okay, so we want to make sure we don't mix up where those are either. So to solve this, we're going to just multiply through by 3 so we can get rid of this fraction out of here. Remember we said we hated fractions. We always want to try and clear those up as soon as possible. So we multiply through by 3 and we have negative 21 is less than or equal to x minus 5 is less than negative 9. Okay. So then we want to add 5 so we can get rid of that and get the x by itself trapped in the middle. We add 5 and we're going to have negative 16 is less than or equal to x is less than negative 4. Now just because these are both negative, that doesn't bother us because negative 16 is still less than negative 4. So we have an okay interval here. So then we're going to draw our number line again, and this time we're going to get mixed notation on our interval because we're going to have a square bracket on this side with negative 16, and up here we're going to have negative 4 with the parenthesis. So we're going to have closed on one end and open on the other. Okay, and we're still going to just take this and we're going to translate it down to get our interval. We have negative 16 to negative 4. Okay. Now, the first thing we want to do is we want to get rid of this 1, because we want our x term by itself, just like when we were doing linear equations. So we're going to subtract 1 from each of the 3 parts, and we have negative 1 is less than negative 4x is less than 4. But then we need to take care of this negative. Now remember, I've already reminded you once, we need to really make sure we pay attention to this. When we have a negative, like this negative 4 here, and we're about to divide through by that negative 4, whereas before we would just flip the 1 inequality, here we have to flip both of them. Okay? So we're going to divide by negative 4, extend that there, negative 4, and negative 4. But we have to remember right here, we want to flip both of those less than signs. So the negatives here are going to cancel, and we're going to have 1/4, flip that around, is greater than, these cancel out, 1/4 is greater than x, is greater than 4 over negative 4, it's going to give us negative 1. Okay? And again, it kind of looks funny to us when it's flipped this way, so sometimes we want to just turn it all the way around so that our smaller values are on the left, our bigger ones are on the right, and it looks normal to us. So that way when we go to draw on our number line, we'll have negative 1 on the left and this positive 1/4 on the right, which gives us our interval negative 1 to 1/4. Okay. So same idea here. We're going to subtract 5 from each of these 3 parts, minus 5, minus 5, minus 5. That's going to give us negative 8. Ooh, sorry about that. It's going to give us a negative 8 here is less than or equal to 3/4 x is less than or equal to negative 3. Now, instead of multiplying through by 4 and dividing by 3, we can just multiply by the reciprocal of 3/4, which is going to be 4/3. So we're going to have negative 4/3 times 8 is less than or equal to 4/3 times 3/4 x is less than or equal to negative 3 times 4/3. Okay? So now these 3's cancel out. So that's good. Over here nothing's going to cancel out, so we need to remember our fraction rules. We're going to treat this 8 like it's 8 over 1, and we're going to multiply our numerators, which is going to give us negative 32 over our denominators multiplied together 3, negative 32/3. That's going to be less than or equal to, this all goes away, our x, which is now nicely trapped in the middle, is less than or equal to, that canceled out, and we just have negative 4. So again, we're going to draw our number line, and on this side, remember we have less than or equals here and here, so we're going to want to use square brackets on both ends this time. So we're going to have negative 32/3, and then on this end, we're going to have negative 4. So then when we go to write our interval, we're going to use the same square brackets. We're going to have negative 32/3, and it's going to go up to negative 4. So I hope that helped. That's all we really need to know about compound inequalities. They're basically just inequality problems again, right? And we can look at each one of these. If we cover up this part, then it's just a regular inequality problem like we've seen before. And the same thing if we covered up this side. Then we look at this part, and it's an inequality, just like we've seen before. So all we're really doing now is we're taking it and we're just doing 2 different problems at the same time. We're finding the home of where that x is going to live. Thanks, and I'll see you guys later.